Hello students, welcome to Sri Jayendra's Rank Zone classes. I'm your friend and mentor for coming classes with respect to physics. This is lecture number 1 of a unit system of particles and rotational motion. So let's begin with today's class. In today's class we are going to discuss about the center of mass. So let's begin then. What is center of mass? We can say that it is defined as the point at which the whole mass of the body is supposed to be. Please however be careful. The whole mass of the body is supposed to be concentrated in order to, supposed to be concentrated in order to study the motion of the body due to an external force in accordance with the Newton's laws of motion. And this could be understood, understood by a motion of a rigid body which is a combination of translatory and rotational motion. If you observe this figure carefully, then you will observe that a certain person is there, and that person is trying to balance the ruler with one of its finger. Even we have tried it at our home. He has used a ruler. We have used different things. We have footballs. We have basketballs that we used to balance with a single finger. We have stainless steel plates were there, which we used to have food, and that different kind of objects. We have tried this with the books. So in that all time when we used to balance it with a single finger or with a point of a pen, we by trial and error we find a certain location that if we put my finger at that point, that object can be balanced. That point is generally the center of mass of that particular object. I hope this is clear. So it is that point of an object which which we assume that the total mass of the body is supposed to be concentrated over here. I hope this is clear. Now is it clear? Is it clear? Great. So let's just find out the position of center of mass of regular bodies. The position of center of mass of depends on the shape of the body and distribution of mass. In the case of symmetrical bodies in which distribution of mass is homogeneous, center of mass coincides with the geometrical center. So you need to find out just the geometrical center, and that geometrical center will be the center of mass, of the object. And let's say that center of mass of the certain regular bodies, let's take one of the case, it's a case of a uniform road, something like this. Yes, that let's suppose this is uniform road, then the center of mass of this uniform road will be at this center. It's a midpoint of the road. The second one is the cubical box. For the cubical box, something like this. Yes, for the cubical box, the center of mass is the midpoint of this box. Yes, we can say it's a point of intersections of body diagonals. Yes, something like this. So here it is going to intersect. So these are the points where center of mass is lying. Let's have some more some more objects, just as a circular ring. For the circular ring, its center of mass would be the geometrical center of the ring. For circular disc, something like this, that this is the ring and its center of mass would be at the center. Now I want to emphasize on one of the point, that what was center of mass. Then when we define center of mass, we used to say that it is supposed to be, it is not to be, we have said it is supposed to be concentrated over the object. Look at the case of the ring. In the case of the ring, you understand that only mass has been distributed only this segment. Yes, mass is there, but only in this segment. A center of mass is at the center of the ring, where no mass is present, where no mass is present. So that means center of mass could be could be out of the body. When I say out of the body, when I say out of the body, please try to understand that I mean that it could be at the location where no mass is there. It could be at the location where no mass is there. So does it clear? Great. So now let's take the circular disc. It is the geometrical center. For the certain spheres, it's a geometrical center of the spheres. Let's take a case of cylinder. Again, it's a center, something like this. Yes. For the triangular, for the triangular laminar sheet, yes, it is just the midpoint. We can say it's a centroid of that triangle. A square plate could be there. Then it is just the bisection, or it is just the intersection of the diagonals. Same is true for the rectangular plates as well. So this all are the cases where if we need to find out, the center of mass in those locations, what I need to do is I need to just find out the geometrical center, and the geometrical center of this body will behave as the center of mass of this body. Yes, one more conclusion is that center of mass lies nearer to the heavy mass. This is true always, in every case. This is true. I hope this is clear. Is it? Now let's. This was the approach. This was the approach. Just we can say it's a geometrical approach to have a center of mass. Now let's just find out. Let's just find out the mathematical approach to find out the center of mass. So we are just working for to find out the coordination of center of mass. So from the coordinates we will have the location of center of mass from the origin. So let's begin then. Let's consider a system of two particles along the x-axis. The particles are placed at A and B at distances x1 and x2 from the origin. So this is particle A, this is particle B, and this particle A is at the distance x1, and this particle B is at a distance of x2 from the origin. The masses of the two particles are m1 and m2 respectively. Let the center of mass, let the center of mass of the system be at C, at a distance of, we can say this is at a distance of x center of mass from the origin. So let us consider that A to C, this distance is d1, and B to C, this distance is d2, and A to B, this is distance t. So to keep the system in equilibrium, the moment of force of the particle about the center of mass due to gravitational force must be equal. So what I need to have is that moment of force must be equal. Yes, such that system would be in an equilibrium. That means net force on the system should be equals to zero. So let's just define first the moment of force. When we say moment of force, we mean it's a force multiplied by perpendicular distance from a particular point. Now in my case, it is the location of center of mass, so it's a moment of force is equals to force multiplied by perpendicular distance from the C. So now in this case it's an F1 into FAC. It's an F1 into AC. That should be is equals to F2 into BC. Why this two can be equated? Because what you understand is that F1 is trying to rotate it. If you keep this fixed from this point C and you just look at this, that F1 is trying to rotate this system. That means it is the force acting on M1, so it is trying to move the particle M1 in the anti-clockwise direction, while F2 is the force, which will try to keep it rotating in the clockwise direction. I hope this is clear. So one in the anti-clockwise direction, another in the clockwise direction. So those two moment of force should be equal, so that system is in equilibrium. So what you need to write is it's an m1 into AC, that should be is equals to m2 multiplied by BC. Yes, basically we have written m1g into AC is equals to m2g into BC, and then then GG has cancelled. So now we know that A to C, it's a distance d1, so this is m1 d1, and B to C, it's a distance d2, so this is m1 d1, that should be is equals to m2 d2, and the d1 could be written as xcm minus x1, d2 could be written as x2 minus xcm. So this is just the m1 into xcm minus x1, that should be is equals to m2 into x2 minus xcm. So this is m1 xcm minus m1 x1 is equals to m2 x2 minus m2 into xcm. So from this we have this relation that xcm is equals to m1 x1 plus m2 x2 upon m1 plus m2. I hope this is clear. Is it clear that this xcm should be equals to m1 x1? xcm should be equals to m1 x1 plus m2 x2 upon m1 plus m2. Does it clear? Does it? Great. So now let's analyze the relation that we have derived. We understood that if two particles have same mass, that means m1 is equals to m2 is equals to m. If these particles have a same mass, m1 equals to m2 is equals to m, then xcm, it's a center of mass from from in the x plane, or we can say in the x direction, is x1 plus x2 by 2. It means the above equation indicates the position coordinates of center of mass of two particle system along a line or on the x-axis. So such as if we are having an n particles, each of mass m1, m2, m3 and up to mn are situated along the x-axis at a distance of x1, x2, x3 up to xn from the origin, then the coordinate of the center of mass of the system can be calculated as that xcm would be equals to m1 x1 plus m2 x2 plus m3 x3 up to mn xn divided by m1 plus m2 plus m3 up to mn. And this could be written as sigma, sigma, yeah, it is just the addition from 1 to n mixi divided by sigma I is equals to 1 to n mi, where sigma mi means it's a total mass m, which is the total mass of the body, and thus xcm could be written as sigma mixi divided by capital M. So does it clear? Does it? Are you sure? Are you sure? Great. Now let's just check certain factors on which center of mass depends. It's a dependency of center of mass. First, center of mass of a system depends on the masses of the particle. Second, on the position of the particles relative to one another. And third, it's a does not dependency, but you need to check this. It's a center of mass does not depend on the reference frame used to locate it. This is very important aspect, that it doesn't depend on the reference frame. That if you have chosen the different origin, if suppose as a user chosen the different origin, then location of center of mass or the position of center of mass does not change. Yes, center of mass will remain at the same position, whatever could be the reference frame or whatever could be the reference point. We will going to see this. Yes, so please keep this in mind, and we are going to cover this in the same session. Now now let's suppose it was the case, this is the case when we have derived that, when we have just kept in mind that all the masses are placed in the x-axis only, and you need to find out the center of mass of the system. But now let's suppose the object is not in only one line, it is in plane. Let's say it is in the xy plane. So what would be the relation? The relation would be that let's have a look. That two particles are there. They are having a masses m1 and m2, and they are located at points x1 comma y1 and x2 comma y2 in the xy plane. If the center of mass is located at xcm comma ycm, if the center of mass is located at xcm comma ycm, then xcm can be given as m1 x1 plus m2 x2 divided by m1 plus m2, and ycm can be given as m1 y1 plus m2 y2 divided by m1 plus m2. So if above system is located in space, center of mass could be written as xcm is equals to m1 x1 plus m2 x2 upon m1 plus m2. ycm is equals to m1 y1 plus m2 y2 upon m1 plus m2. zcm is equals to m1 z1 plus m2 z2 upon m1 plus m2 if system is of n particles having masses from m1 to mn, then xcm could be written as sigma I is equals to 1 to n mi xi divided by sigma I is equals to 1 to n mi. A same way ycm could be written as sigma I is equals to 1 to n mi yi divided by sigma I is equals to 1 to n mi. zcm zcm could be written as sigma I is equals to 1 to n mizi divided by sigma I is equals to 1 to n mi. Yes, so this is just the xcm, ycm and zcm. Yes, this is the system of n particles having masses from m1 to mn. I hope this everything is clear. Is it clear? Just keep all these things, all these parameters in mind, and we are going to use each and every aspect that we have learned up till now. Yes, yes. Now, a different approach. Let's have a look at the different approach to find out the center of mass. Let's suppose understood that if a system consists of two particles of masses m1 and m2 with their position vectors r1 and r2 with respect to origin O, then position vector of center of mass can be given as that rcm is equals to m1 r1 plus m2 r2 upon m1 plus m2. While if I locate the r1, let's have a look at this. It is the one distance. It is at x1 distance in the x-axis, and if I understood their y position, it is at the y1 position in the y-axis. So r1 it's an x1i plus y1j. Same way I could locate the m2 particle, that it is at x2 location. It is at x2 location from the origin, and this is at y2 location. This is at y2 location from the origin. So r2, this is equals to x2y plus y2j, and same way rcm, the rcm could be written as xcm I cap plus ycm j cap. So if we generalize the above statement for a system consisting of n particles of masses m1 m2 up to mn, and their position vectors could be written as r1 r2 up to rn respectively, then the position vector of the center of mass can be written as that rcm is equals to m1 r1 plus m2 r2 up to mn rn divided by m1 plus m2 up to mn, and this rcm could be written as sigma I is equals to 1 to n miri upon m, where m is the total mass of the entire body. So does it clear? This is the second approach to define and to locate the coordinates of center of mass. So does it clear? Does it clear? Now let's have a look at the certain characteristics. Let's have a look to the certain characteristics of center of mass. Let's have a look. We can say that center of mass may be, look at word may be within the body or outside the material of the body that we have discussed. For the ring center of mass is lying at the center where no mass is there. Yes, on the body there are several cases that you even understand, but outside the body, please remember this example. Yes, it is not necessary that mass should be present at the center of mass, such as in the case of a uniform ring. Center of mass is outside the material. Center of mass is outside the material where no mass is present. Does it clear? Does it? Great. The location of the center of mass is independent of the reference frame used to locate it that we have discussed while we check the dependent and not depending factors. And one more thing, it's a center of mass of a system of particle depends only on the masses of the particle and their relative positions. It does not depend on the reference frame. So does it clear up till now? Any doubts up till now? Is there anything? Is there anything? Is there? No? Great. Let's look at this question. Where is the center of mass located for an uniform ring? First, at the geometrical center, outside the material where no mass is present. Yes, these two are correct. So its answer should be both A and B. Within the body? No. It is at the place where no mass is there. So could not be said or could not be correct to say it's a within the body. Let's look at the next question. The position of center of mass depends upon the length of the body and the distribution of mass. It depends on the size of the body as well as it depends on the shape of the body. So both A and B could be the correct, and the position of center of mass depends on the geometrical center would not be the correct to write this. Yes, because this is not possible at every time. This is simply not possible at every time that it is at the geometrical center. So both A and B, this would be the correct answer. Next, the location. The location of the center of mass is blank of the reference frame used to locate it. The location of center of mass is independent of the reference frame. It is not at all depending. It is not at all depending on the center of mass. Yes, I hope this is clear. So this were all the MCQs, or we should say this all are the theoretical approach. Now let's have the numerical approach. So be ready with your pen and paper and just do it as I'm doing it. Yes, so let's assume that this is the mass 1, this is the mass 2, this is of 10 kg, this is of let's say 4 kg, and they have been connected with massless rod, and the separation between these two is the 10 meter. So what they want that find out center of mass of given system. They say that find out the center of mass of given system. So what I need to do is I need to choose certain reference frame from which I'm going to write down the coordinates, and I will be having a formula. Let's suppose I have chosen the center of reference frame at here, and this is just the midpoint. When I say midpoint, this would be the phi, even this would be the phi. So if I write down the coordinates of this 4 kg body, because I understand this is 0 comma 0, so this would be the 4 comma 0, and s as it is on, sorry, this is 5 comma 0, and this as it is on the left hand side of this, it's a minus of 5 comma 0. Yes. So let's just check it out. The center of mass of the system, we can say it's an x here. That would be equals to m1 x1 plus m2 x2 divide by m1 plus m2. First mass, it's a 4 kg. Its coordinates, it's a 5, plus second mass, it's a 10 kg. Its coordinates, that means minus of 5, divide by m1 plus m2. This is 10, this is 4, it's a 14. So this is 4 5s are 20, minus 10 5s are minus of 50, divide by 14. This is 20 minus 50. This is minus of 30 by 14. And when I say minus of 30 by 14, it's a 15 twos are and 7 twos are. So this is minus of 15 by 7. Minus of 15 by 7. This is approximately minus of 2 point something. While I say minus of 2 point something, that this is my zero location. Minus 2 would be at somewhere here. I hope this is clear. So this could be the location of center of mass of an object. Yes, and if this is 2, from here it is approximately 3. Approximately, yes. I hope this is clear. Is it clear? Is it? So this is the answer with when I chosen reference frame or reference position at the midpoint of the system. Let's just try it out. Let's just try it out one more time with a different reference point. Let's just do it and then discuss the points. This was the system. This is a 10 kg body. This is a 4 kg body. This was the separation between these two were the 10 meter. Now, what I need to do is I need to just find out the reference line. Now, let us suppose I choose the reference line over here. So, I will choose this as a 0 comma 0. So by default this becomes a 10 comma 0 because the separation between this two is the 10 meter, and there is no masses on the y-axis, so no need to write dimensions or coordinates of y. Now let's calculate the center of mass, that is xcm, that would be equals to m1 x1 plus m2 x2 divided by m1 plus m2. Got it? Now what is m1? It's a 10 kg multiplied by coordinates, it's a 0, plus m2, this is a 4 kg body, multiplied by x2, this is of 10, divide by m1 plus m2, this is 10, this is 4, this is 14. So that is 0 plus 4 tens are 40, divide by 14. So this is 40 by 14, this is 20 by 7. This is x center of mass. While I say x cm, this is 20 by 7, and when I say 20 by 7, it is somehow less than 3, approximately 2.9 something, approximately. Yes, because 7 threes are 21. Yes. So while I calculate 3, or I should say it's a 2.9, it would be somewhere here from this. This is the location. This is the location of COM. It's a center of mass. So now observe this. Observe this. This is at 2.9 meter from the 10 kg. Now look at this. When I have chosen the reference frame at a midpoint, even it was approximately 2.1 from here. So from 10 kg it is 2.9 only. So from the 10 kg it is at that location only. So first thing we have proved that center of mass, it is a position where total mass of a system is about or assumed to be concentrated, which does not depend on the reference frame chosen or origin chosen. You can choose origin of your choice, but location, or I should say position of center of mass will be the same. First thing are different. Now this, let's discuss the second aspect. That, look at this 10 kg body. This is 4 kg body. Their midpoint would be somewhere here. Yes, this is the midpoint. Center of mass is nearer. Center of mass is nearer to the body, which is having a higher mass. Yes, this is 4 kg, this is 10 kg. Body having 10 kg is having a higher of mass. And when it is having higher mass, the center of mass resides nearer to the heavier body. I hope this is clear. Is it clear? So center of mass depends on the masses of the particles, as well as it depends on the distribution of the masses and relative separation between these two masses. Is it clear? Does this every aspect that we have discussed in the theory sessions as well, is it clear by this numerical? Is it? Great. Now let's work for the questions. Do it quickly. Suppose the system is given as that, something like this. Here one mass is there. This mass is 2 kg. This mass is 4 kg. This mass is 6 kg. This is of 2 meter. Even this is of 2 meter. So what they want? They want that, find out center of mass of the system. This is just the requirement, find out center of mass of the system. So what we can do is this is 4 kg, this is 2 kg, this is 6 kg. If I choose that coordinates, first I need to choose the reference point, that this is the location on which I will assume my origin. How to choose origin wisely? First, this all are the necessary steps. I could not say that this is the must step. You need to do it always. No, this is not like this. This is just the advice you to use this so that your calculation would be a lesser. And when calculation would be a lesser, the things will be much better and much faster. So what I prefer is that always choose the reference line such that it passes through at least one of the body. So now if I assume the reference line, I will assume this one, that this is my x-axis and this is my y-axis. Yes, this is x, this is y. So if this is x, this is y. This could be 0 comma 0. This could be a 2 comma 0, and this could be the 0 comma 2 because it is on the y-axis where x is 0. I hope this is clear. Is it clear? Is it? So now let's just do it. It's an xcm that would be equals to m1 x1 plus m2 x2 divide by m1 plus m2. Sorry, we have three objects. It's an m1 x1 plus m2 x2 plus m3 x3 upon m1 plus m2 plus m3. I know that here the system is in x and y plane, so I need to write down the ycm as well. But let's just initially solve for the xcm and then we will move for the ycm. So this is first object 4 kg, x coordinates of it's a 0, plus m2, it's a, let's say 6 kg, x coordinate of it's a 2, plus third object it is of 2 kg and x coordinate of this it's a 0. Divide by m1 plus m2 plus m3, it's a 4 plus 6, 10, 10 plus 2, it's a 12. So this is equals to 4 comma 0 0, 2 comma 0 0, it's a 6 2s are 12, divide by 12, this would be the 1, let's say meter. Now same way I need to calculate the YCM, which could be given as m1 y1 plus m2 y2 plus m3 y3 divide by m1 plus m2 plus m3. While I doing this, if I am having the value of this, it's a 4 comma 0 plus it's a 6. This is first is the x, next is the y. It's a 6 comma 0 plus 2 into 2 divide by m1 plus m2 plus m3. It's a 4 plus 6, 10 plus 2, 12. So this is 2 2s are 4, this is 3. It's a 4 by 12. It's a 1 comma 3 meter. So let's just try to locate the center of mass on the XCM. On the XCM, it's a 1 meter. So let's suppose understood that this complete is the 2 meter and its midpoint would be at 1 meter. And on the y-axis, it is 1/3. So this is midpoint and it is less than this. It's just 1/3, something like this. So my center of mass would be at somewhere here. This is the location of center of mass and its coordinates of center of mass will be 1 comma 1 by 3 from this as a origin. So while I choose this origin, what benefit I am having is that I do not need to calculate about this location because it ultimately converts to a zero. That mass into distance, that has been converted to zero, and that makes our task very very easy. So does it clear? Now will you be capable enough to do this? Are you sure? Are you sure? Can you do this? Will you be? Can it be done? Can it be? Great. Let's move to the next question. Do it quickly. Let's suppose we have an equilateral triangle and this equilateral triangle have the masses m, 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 and the separation between this masses is the 2l, 2l, 2l. Yes, the separation is 2l, 2l, 2l. Now the question is find out center of mass of the given system. This is requirement, that find out center of mass of the given system. So what I need to do is first thing to choose the origin. So let's suppose I will choose the origin as such as this. This is x, this is y. This could be 0 comma 0, this could be 2l comma 0. Yes, we know that this is the midpoint of this, so its x coordinates will be the l. And what about the y coordinate? So let's assume it a y and first calculate it. This is 90 degree, this is l, so this is just the right angle triangle, and for right angle triangle it's an l square plus y square should be equals to 4l square. So this y square is equals to 4l square minus l square, which is 3l square, and this y should be equals to root of 3l. This y should be equals to root of 3l. So this is l comma root of 3l. This is just the y coordinates. I hope this is clear. Is it clear? Is it? Are you sure? Great. Now we have a coordinates as well, so we can work for the xcm and ycm. Then let's begin with this. It's an xcm, that would be equals to m1 x1 plus m2 x2 plus m3 x3 divide by m1 plus m2 plus m3. Yes, so while I'm doing this, it's in this mass m into 0 plus this mass m into 2L plus this mass m into L divide by m1 plus m2 plus m3, it's a 3m. This is 2 ml, this is 3 ml, so it's a 3 ml divided by 3m, that could be given as an L. This is the xcm. Now let's just calculate the ycm. This would be equals to m1 y1 plus m2 y2 plus m3 y3 divide by m1 plus m2 plus m3. This could be written as this is m, this is y, it's an m into 0, plus this is m, this is 0, plus this is m, this is root 3l, this is m into root 3l, divide by 3m. And while I solving this, it is root 3 into l into m divided by 3m. So this has gone, and this is equals to l by root 3. So its y coordinates, will be the l by root 3, and its x coordinate is the l. So it is something like this, that it would be at l comma root 3l. This is the xcm comma ycm. I hope this is clear. It is somewhere here. Yes, it is somewhere here. I hope this is clear. Is it? Now we can have our coordinates something like this as well. Let's have a look. This is the equilateral triangle, and this was the situation. Yes, our masses are there. We have chosen this as a reference. So this is 0 comma 0, this was the 2l comma 0, and masses of this is required. So what we can do is, this is 2l and this angle is 60 degree. So if this angle is 60 degree, the dimensions of this, it is just the x would be 2l cos 60 degree, and this is, let's suppose this is x, this is y. This could be written as 2l sine 60. So not only on this time, this could be done anytime, that this is, let's suppose, the length multiplied by cos theta, comma, length multiplied by sine theta, and yes, you would be having the x1 y1 or the coordinates of the same. And if you are having a coordinates, you can have the rest of the numericals, that from the m1 x1 plus m2 x2 plus m3 x3 and onwards. I hope this is clear. Does it clear? Any doubts, any concern over here? Is there anything? Is there anything? No? Great. Let's look at this question. It says that a square frame is there, and on the square frame 4 masses are there, each one having a mass of m, and the square frame is having a dimensions of 2l by 2l. So what I need to do is, the question is, find out center of mass of system shown in the figure. So what you need to do is, first task is to choose the location, that where should be the origin, so that calculation could be an easier one. So what I assumed is that, let's suppose, choose this as a reference line. This is y, this is x. So this is x, this is y. That means this is 0 comma 0. This could be written as 2l comma 0. This could be written as 0 comma 2l, and this could be written as 12 comma 12. I hope this is clear. Now when this is clear, this is clear, we could write it's an axiom, that is m1 x1 plus m2 x2 plus m3 x3 plus m4 x4 divided by m1 plus m2 plus m3 plus m4. So if I put up the value, this is m into 0 plus m into 12 plus m into 12 plus m into 0 divide by m. This is just the 4m. So that should be is equals to, this is 2 ml, this is 2 ml, so this is 4 ml divide by 4m, which will be L. I hope this is clear. Is it clear? Is it? Great. Now let's just find out the YCM. The YCM would be equals to sigma MIYI divide by 4m. It's a total mass. Yes. So that could be represented as, this is m, this is 0 plus this is m, this is 0 plus this m, this is 12, and this m, this is 12 divide by 4m. So this would be 2 ml plus 2 ml, this is 4 ml divide by 4m, which would be L. I hope this is clear. So this is what we get. It's an XCM comma YCM, which should be an L comma L. I hope this is clear. So L comma L would be at somewhere here. Yes, this could be the location of L comma L. I hope this is clear. Now if you look this analytically, if you look at this analytically, then even you will have this location. How? Let me help you. That, look at this. This is the M. Even this is the M. Both are having the same masses. Yes. So if these two are having the same masses, the center of mass would rely on this location. It's a center of mass of this two. Let's name it. It's a COM1. Now, now this is mass M. This is mass M. So, and as this both are the same masses, its center of mass would be at this location. It's a center of mass of 2. Now this is the center of mass of this two systems, so their masses is 2m. This is the center of mass of this two masses, so it's a mass of 2m. Again, this is 2m, this is 2m. They are having the same masses, and when the masses are same, the center of mass of this systems is at the midpoint. So this is the answer. Got it? You do not need to go with this XCM, YCM, and even in the case of the space, it would be a ZCM. I hope this is clear. So this is just the analytical approach from where you can have an answer. So let's just practice this kind of approach, because this is very fast, and it is very accurate. Let's have a look. Suppose we have been given that this is the root, this is the root, and this road is having a mass m and length 12. So, and they have been asked that find center of mass of given systems. So what you need to do is, we understand that it's a road. Mass m has been uniformly distributed over the road, so its center of mass would be the midpoint. It is at this location. It could be the L from this end, it could be L from this end. I hope this is clear. So that's it. You do not need to do anything to do this. Now, from based on this, let's suppose I have been asked something like this, that this is my road, this is having mass m, length 12, and this is another road, something like this, Again, this is having mass m and length 12. If I've been asked that find out the center of mass of the system, so what I need to do is first thing, treat this both the objects, treat this both the rods as an individual one. So if I consider this is the first segment of my system, this is the second segment of my system, then let's just find it out the center of mass of this first segment. It is at the midpoint. So this is the mass 1. I could write this. This is m length 12, so this from this length is 12, so its center of mass would be at here. Let's write it down this as an m2. Now, now let's suppose choose the origin. How will you? Let's suppose if I have chosen this as an origin, that this would be the x, sorry, this would be the x and this would be the y. So the system is, my system is something like this, that this is the x-axis, this is the y-axis, this is 0 comma 0. Now this is the mass m1, which is at the L distance, from 0 comma 0, and this is the second mass. It's an m2. Again, we know that this m1 and m2 is same, but here I have written m1 and m2 so that confusion can be avoided. It's L comma L. Let's just write down the coordinates. It's an L comma 0, and this is as it is in y and it is in negative y, it's a 0 comma minus of L. Now just write down the xcm ycm. So xcm could be written as, it's an m into L plus this m into 0 divided by total mass, it's a 2m. So this is ml divided by 2m. This is equals to L by 2. Yes, this is ml divided by 2m. This is L by 2. Now what about the ycm? Ycm, this is m1, this is 0, so this is m into 0 plus this is m into minus of L, this is m into minus of L divided by 2m. So this is equals to, this could be gone, and this is minus of L by 2. I hope this is clear. So this location would be the L by 2 comma minus of L by 2. This length is L, so it is the midpoint of this system, and even it is midpoint of this system. So this could be the location of center of mass. It's L by 2 comma minus of L by 2. This is one of the approach and the simplest approach that we have gone through this. I hope this is clear. Now, do you want to see one more approach? Have you? Let's have a look. If you understand that this is, shall I redraw this? Okay, let's have a look. I will redraw this. The system was something like this, and I understood that center of mass of first object is at here, center of mass of second object is at here. Yes, so the system is here. I am having first mass, and on this line, another object is there having mass m, and I don't know the exact separation between these two, but what I am knowing is that this distance is L and this distance is L. So I know this is root 2L, that can be understood from the Pythagoras. Yes, but now my concern is, this is m, this is m, and I want to find out the center of mass. So look at this. You must consider always, this is for always, that center of mass is lying on the line connecting two bodies. So it should be, the center of mass should be from this point to this point, anywhere. Yes, but as both the masses are equal, this would be at midpoint of this. This is the final COM, center of mass. That's it. You have done the same thing over here. Look at this, that this separation this separation was L, and you are having an answer at L by 2. It is a midpoint from the x-axis. again this separation is L and you are having an answer at minus of L by 2. Minus just represent that from your reference it is at the below the points. So it's an L by 2 comma minus of L by 2. This is the same thing. I hope this is clear. Is it clear? Is it? Great. Now one more thing. One more thing. If this is the origin, we understood that this has been chosen as an origin. This is L, this is L. So this could be this. The total distance is root of 2L. I'm talking about this distance. And the half of the distance could be written as L by root 2. L by root 2. If I want to calculate the distance of center of mass from the origin, if I need to calculate this, how will you do it? X. How will you do it? So what I understood is that this is L. This could be written as 90 degree. Yes. This is 45 degree. Even this must be the 45 degree. So what I can have is that X could be written as X could be written as X is equals to, let's say this as a theta so that you can have a generalized relation, that X would be equals to L cos theta. In this case this theta is 45 degree, so it's a L cos 45 degree. This is equals to L by root 2. That's it. It is the distance, it is the distance of COM from the origin. So now will you be able to do each thing, everything like this? Will you be? Is it possible for you to do this all stuff? Are you sure? Are you sure? Can it be done? Can it be? Yes. Ready for one more question like this? Let's have a look. Let's suppose, let's suppose they have given that. Yes. Thus one system, and this is the second system. This is the third system. Yes. Each one having mass m length L, mass m length L, mass m length L. Yes. And what do you need to do? Find out the center of mass. The question is, let's choose on the reference first, that this is the reference line. This is the reference line. Let's have a look. Yes. Question is find out COM of given system. So I will do this with both the approach. First from the approach of the numerical data, and another is the analytical approach. So what I need to do is just find out the center of mass of each object. This would be at here, and this is at L by 2. This would be at here, and this is L by 2. From this is at L by 2, and as usual this distance is L. So let's just write it down. Let's just write it down. Coordinates the coordinates of each object. This could be written as, look at this, this is X, this is Y. So this yes, this would be the 0 comma 0. This locations could be L by 2 comma 0. This would be the 0 comma minus of L by 2, as it is below the y axis, below the x axis, sorry. And this it is in the positive x, so this is L comma minus of L by 2. So now what you need to do is just find it out, the XCM and YCM. Let's begin with the XCM. This is the first object. Let me give the number. It's a first, that's a second, it's a third. So this XCM could be written as could be written as this is m into L by 2 plus this m into 0 plus this m into L divide by or whole divide by this m, this m, this m. This is 3m. So that should be is equals to this is 0. This is m into L by 2. It's a half m into L plus ml. So it's a 1 plus half. It's a 3 by 2. 3 by 2 into m into L divide by 3 into m. This has gone. This has gone. And this is equals to L by 2. This is the axiom. This is the center of mass in it's a coordinate of center of mass from the x-axis. Now for the YCM, let's work for it. It's a y-axis m into 0. For this, it's an m into minus of L by 2 plus m into minus of L by 2 divide by m plus m plus m. It's a 3m. So it's a half ml. It's a half ml. Half plus half. It's a 1. So this is ml again in minus divide by 3m. So this is equals to this has gone, and this is equals to minus of L by 3. So it's xcm and ycm. It's an xcm comma ycm could be written as L by 2 comma minus of L by 3. Got it? Are you clear? Are you? So any doubts? Is there anything? Is there anything? No? Great. So now this is the first approach. This is the first approach using which we can derive this. Let's have a look a second approach as well. This was the analytical approach, and let's begin then. System is something like this. This is first road. This is second road. This is third road. Center of mass of this is at here. Center of mass of this is at here. Center of mass of this is at here. Each is of mass m length L. Mass m length L. Mass m length L. So what you need to do is first you need to calculate. First you need to calculate the center of mass of any one of the object, any one of the system. So each one it's an ml. Now what you need to do is consider any two systems and find out the center of mass. Let's choose this and this and connect them using a line. We know that center of mass is always on the line joining the two bodies. So it is mass m, both are having the same masses, and when both are having the same masses, it is at the midpoint. So here the center of mass would be there. But this center of mass contain a mass of this body plus this body, so this must be 2m. I hope this is clear. This must be written as a 2m. Now what you need to do is let's pass the reference from this line. Yes, it is something like this. I want to find out only this location. Yes, we are not allowed to change the locations, but we just calculate this. So what I need to do is it's an YCM that would be equals to, if this has been passed from 0, it's a 0 comma 0, and this is the L that you can see. It's a 0 comma minus of L. So YCM it's an m into 0 plus this is 2m into minus of L divide by total mass, it's a 3m. So this is 2m minus of 2ml divide by 3m. So this has gone, and that would be given. It's a minus of 2l by 3 from this. So if I calculate the coordinates with reference to this whatever the given system, it's an x, this was y, it was given, this was the mass m, the center of mass was lying on this, and sorry, this is where the 2m was lying, this is this distance where L, and in YCM it is at minus of 2L by 3, minus of 2L by 3. It's approximately 66 percentage, and it is at the L. So this would be the location. It's an L comma minus of 2L by 3. These are the x coordinates and y coordinates of the center of mass. Yes, these are the x coordinate and y coordinates of center of mass. I hope this is clear. This is just the YCM. This is just the YCM. Now I need to find out the x coordinate as well. So how to calculate the x coordinate? How to calculate the x coordinate? How can I do this? How can we? What I need to do is, this is YCM. So same way, if I have chosen this as a 0 comma 0, if I have chosen this as a 0 comma 0, then XCM should be on this line only. Yes, let's choose this as an origin. And if I have chosen this as a origin, if I have chosen this as a origin, this is 0 comma 0. This would be at location L, and this would be even at location. These are the coordinates. It's now L comma minus of L, and then you can calculate the XCM accordingly. And if you have calculated accordingly, this is this could be written as L by 2 comma minus of 2L by 3. If you choose this, if you calculate this from here, this could be written as L by 2 comma minus of L by 3. Yes, so this is the situation how you can calculate this. This is how you can calculate it from the analytical point of view. I hope this is clear. Is it clear? Is it any doubts over it? Is there anything? No? Great. Now let's discuss something very important. We have when we say that COM, it's a center of mass of discrete mass distribution system. That means when we have this as an M1, M2, and such as Mn, and they are at distance of x1, x2, and such as xn, what we can do is we have this xcm or ycm and zcm, that is equals to m1 x1 plus m2 x2 up to mn xn divide by m1 plus m2 up to mn. We have this methodology. This is first. Now next is the case it is the center of mass of uniformly distributed mass. So we have three terms defined. Let's have a look that. Let's suppose a road is there. This is having mass m, length l. We have lambda defined for it. It's a mass m, length l. So this is what we call as a linear mass density, and even this could be written like this. It's a lambda is equals to dm by dl, and their unit is kg per meter. Their unit is kg per minute meter. You can calculate the dimensions. First thing. A second thing, let's suppose a square plate is there. Let's suppose this is L and this is B. I understand that it is a square, it would be an L by L, but for the reference point that for any object we can write it down, that's why I have written it's an L cross B. Yes, we have defined it's a sigma. We have defined sigma, which is equals to m by a. This is we can say areal mass density, and that could be written that could be written as sigma is equals to that could be written as sigma is equals to dm by dA. That should be is equals to kg per meter square. And one more, let's suppose we have a certain cube. Yes, the sides are L by L by L. So we have a row which could be written as m by v. This is volumetric mass density, and that could be written as sigma is equals to dm by dv, which could be written as kg per meter cube. So this three distribution are there. This three distribution are there when it's an object of 1D. We call it as a one dimension. It is the mass divided by length. When it is the object of a 2D, it's a two-dimensional object. We understand that the total mass will be distributed. Total mass will be distributed on the surface. So that we call as a surface mass density or areal mass density. Certain authors write this as the superficial mass density. Yes, but in those situations, mass of an object has been distributed on a complete area, complete surface. The third one is the when object is in 3D. It's a three-dimensional object, and we used to say that let's suppose a cube is there and cube is having mass m. So when I say cube is having mass m, this total mass m is being distributed. This total mass m is being distributed on the complete volume of that object. So that's why we can call this as the volumetric mass density. I hope this is clear. So is it clear? Is it clear? Can we use as a numerical? Yes. Please write it down. Please write it down, this lambda, sigma, and rho. This will help us. Have you written it? Have you? Have you written it? Are you sure? So let's have a look how they are being asked. Let's suppose the question is that this is a square plate and this is having mass m, and their length is 2r. It's a 2r comma 2r, and on this a circular plate is there. We can say circular disc, and this is its center, and this is of radius r. Even this is having mass m. So a square plate is there having mass m, and the length, that means the dimensions is 2r by 2r, and the circular plate is there, it is having mass m and radius r. So they ask that find out locations, or find out locations where center of mass of this system is. Find out location where center of mass of the system is. So this is required. You need to find out the location of center of mass. While they prefer location, where they'll find out where they prefer location of center of mass, what they want is they want actually that center of mass is within square plate or circular plate. So this is what they require, that where is the center of mass of this plate, of this combined system, sorry, that is it in the square plate or is it in the circular plate. So what I need to do is that first thing is choose the center of mass of each one individual one. The center of mass of this object would be here, and the center of mass of this object would be at here, at this point. Yes, this is the distance r, and this is the distance r. Yes, so what I can do is that for circular plate I can write this m. Let's choose this as a boundary. While choosing this, I have chosen this as a boundary. That's why if my answer is in positive, that means it is in the circular plate. And if my answer is in negative, that means I will understood that it is in the square plate. So let's have a look. This is mass m, this is mass m, this is the distance r, this is the distance r. As these two are the same masses, their center of mass would be at the midpoint of them, and it is at this position. This is the location of center of mass of this system. So the center of mass would be at there. So it is not on the circular plate, or it is not on the square plate. It is just on the boundary. It is just on the boundary of this plate. So this is the case. This is the case when m1 is equals to m2 is equals to m. Both are having same masses. This is the case. Is it clear? Is it clear? Are you sure? Can you do this? Can it be done by you guys? Can it be? Are you sure? Great. Now, let's add up this certain thing in the previous question and rewrite it. That the situation is something like this, that let's suppose this is boundary. This is the square plate having dimensions of 2r by 2r. This is circular plate. This is yes, one more time. Yes. So this is the circular plate, and this would be the center, this would be the radius r. If we are not having any data about their masses, so at this point of time I am just writing m1 and m2. What they given is, let's check that if sigma 1 is equals to sigma 2. What is sigma? It's an areal mass density. Yes, if sigma 1 is equals to sigma 2, where should be the COM of given system? This is the requirement. They have given that sigma 1 and sigma 2 are equal. Both the sigma, that is the areal mass densities, are equal. You need to find out that center of mass is now lying on the circular plate, or center of mass is lying on the square plate. So what I need to do is I'm going to have the same thing that I have done in previously, that this is the center of mass of first system, this is m1. Let's suppose this is the center of mass of the second system, this is m2. Let's keep this as a boundary. So if I doing same thing, this is the situation, this is the location 1, it's an m1. This is the location 2, it's an m2. This distance is r, even this distance is r. So what I need to do is I need to write down the YCM. Let's have a look. It's a YCM that would be equals to, this would be the m1 into r, minus of, why minus? Because it is the below the line, minus of m2 into r, divide by m1 plus m2. Now how could I write m1 and m2? What I can write is that I am having an sigma is equals to mass by area. So we can have m is equals to sigma into area. So if this is the master relation, I can have m1, this is the first object, this is the second object. M1 would be equals to sigma multiplied by pi r square. Accordingly, M2 could be written as sigma multiplied by 2r multiplied by 2r. It's a 4r square. So I can write like this. This would be equals to YCM. This is equals to m1 that is of sigma into pi r square multiplied by r minus m2, it's a sigma into 4r square multiplied by r divide by addition of this, it's a sigma into pi r square plus sigma into 4r square. I hope this is clear. So I have been left with the we can say it's a sigma into r square r into r, it's an r cube. Even here it's a sigma into r square into r, this is sigma into r cube. So this is sigma into r cube in bracket, it's a pi minus of 4 divide by here sigma into r square could be common, sigma into r square divide by pi plus 4. Got it? Are you sure? So in this situation, the situation is it's an YCM that is equals to sigma into r cube divided by sigma into r square multiplied by pi minus of 4 divide by pi plus 4. When I'm doing this sigma and this sigma could gone, this r square and this r would gone. So this is the var YCM is equals to r into bracket pi minus 4 divide by pi plus 4. Now this is the location on this is the value of YCM. Yes, but now if I have been asked that where does it lying? Where does it lying? That means that do it reside within a square plate or do it reside within a circular plate? How could I have an answer? How could I have an answer? So what I'm supposed to thinking is that look at this. If I am having an analytical study of this is pi, which is 3.14. This is 4, it's a minus of 4. When I do this, the answer would be whatever it could be, but it is less than 0. So this YCM would be less than 0. It is in negative. And when this is in negative, this has been chosen as a 0 line. So negative would be below this. If positive, it would be an in this. So it is the center of mass of this system when both are having same sigma. We can say it's the same areal mass density. Then the center of mass of this system would be residing in the square plate. I'm sorry. Yes. So let me rewrite this. It's a center of mass of the system will be in square plate when both are having same sigma. I hope this is clear. So if sigma is clear, sigma is same and the dimensions are given such as, then the center of mass of the system will be in the square plate. I hope this is clear. So now do you understand this? Do you understand this, that how should we proceed? Are you sure? Are you sure? Any issues over this? Is there anything? Is there anything? Are you sure? Are you sure? Great. Now let's have one more type of question with that have been associated with the center of mass. Let's suppose understand that this is pure logical approach. Pure logical approach. You must feel this, that how this could be done. Let's suppose this is a square plate and the square plate is having a dimensions of 12 by 12, and let's suppose this is having mass m, and this is the x-axis, this is the y-axis. So one of them is x, another one it's in y. So initially, where is the center of mass? Initially, where is the center of mass? When I say initially center of mass, then I should say that center of mass would be at this position. This is the position where center of mass would be lying. Now, suppose if I remove this, please have a look very carefully. Suppose if I remove this segment, now this segment has been removed. Where could be the center of mass? I don't want the exact location. I don't want the exact coordinates of center of mass. I want only the certain analytical approach, so that with the help of that I am having an approximate answer that this would be the location of center of mass. So what I assume is if this segment has been removed, shall I redraw this? Shall I? Let's have a look. It is something like this. Yes, and this segment has been removed. Then the center of mass of this system would be at something like this. Somewhere here. I'm not talking that it is at the midpoint or something like this. No, it is somewhere here. So this is the second location of COM, center of mass. I hope this is clear. Is it clear? Is it? Now, now. If I removed this part as well, if I removed this part as well, that let's suppose this segment has been removed. If this segment has been removed, where is the center of mass? Where is the center of mass? Yes, again, only this section is having mass, this section is having mass, so again it would be at the midpoint. Again, it is the third situation where center of mass would be at this. I hope this is clear. Please understood this. Please. This is very interesting, as well as this will have a very good approach. So center of mass is at midpoint. Now, if I remove one more segment, let's suppose this segment has been removed. Where is the center of mass? If this segment has been removed, this is the location where center of mass would be. It's L. This is 2L. This is L by 2. Sorry. Even this is L by 2. I hope this is clear. So, so this can be done very easily. I hope this is clear. Can it be? Can it be? Are you sure? Are you sure? Great. So, thus, using an analytical approach, what we understood every time is that wherever the mass is higher, your center of mass will be shifting. So if initially forget about everything, initially the whole four systems were there. This every segments were there. This was there. This was there. This was there, and this was there. My center of mass would be at midpoint. Now, if I have been removed this segment, initially I have removed this segment, then my center of mass has been shifted to this position. Now what I have done is I have removed this system. Then my center of mass again rearrange itself at this position. Sorry, at this position, because only this two having a mass. Now, if I have removed this segment, let's suppose this segment, then my center of mass would be at this location. Yes, so because only this segment is having a mass, and all three the segment has been removed. I hope this is clear. Is it clear? Is it? Are you sure? Great. So, will you be to certain questions based on this? Are you ready? Are you? Let's have a look the question. Let's suppose the system is given like this, and the radius radius of this circle is r. This is, let's say, y. This is the x, and from this disk of radius r, this part has been removed. What you need to do is let's have a check that, find out. Find out center of mass of the system after after disk of radius r, or sorry, disk of radius r by 2 has been removed. Disk of radius r has been removed from the disk of radius r as shown in the figure. Yes. So, first tell me, how shall I do this? Disk is given, and let's suppose assume that this disk, original disk, is having a mass of m, and this disk has radius of r, mass of m, and from this disk a circular section of radius r by 2 has been removed as shown in the figure. So how can I do this? How can I do this? Okay, let's put everything aside. Tell me one thing, that where would be the new center of mass? Maybe I am not looking for the answer having the perfect data. I want just the location, approximate location, that center of mass would be somewhere here, where it would be. If I understood the situation well, I must think like this, that if this segment has been removed, if this segment is going to be removed, this would be the heavier one, and when this would be the heavier one, this will be the location somewhere here, the center of mass would be there. I hope this is clear. Even you have thought like this, do you? Great. Now, as I understood that this is disk, what I can do is let's have a look. It's an xcm, that would be equals to a1 x1 minus a2 x2 upon a1 minus a2. Now let's re-understand what all terminologies is. That a1, it's the original area. When I say original, I mean, when I say original, I mean it is the area. It is the area when system has a complete mass and nothing has been removed. Next, x1. X1 is the from origin distance from origin to the COM. It's a center of mass of original disk. This is x1. Now what is a2 and what is x2? A2, it is the area of removed part, and x2 it is the distance of COM of removed part from origin. So this is our requirement. Yes. So what I understood is that initially the center of mass of system would be at this, and this disk is having this disk. Is it visible? Is it? Yes, now this is visible. Yes, the center of mass of the removed part would be at this, and this complete radius is r. So this is the half of the radius, which I could write it as an r by 2. So let's just put the formula and try to get the answer. This is xcm is equals to a1 x1 minus a2 x2 divide by a1 minus of a2. The initial area, a1 is the initial area. It's, we can say it's an original area when part has not been removed. And when it was the case that part has not been removed, this is equals to pi into r square multiplied by x1. X1 it is the distance. X1 it is the distance from the origin. This is origin to the center of mass of the original system. you will look that this is, we are talking about the same point because this is the origin. Yes, this is the x-axis, this is the y-axis, so this is the origin, and we are, center of mass would be at the same location, so this would be the 0. Minus of area 2, this should be is equals to pi r square by 4 multiplied by x2. It is the distance, it is the distance of the center of mass from the origin. So this is origin, this is center of mass of the removed system, and this would be the r by 2. Divide by a1 minus a2. Area 1, it's a pi r square. Area 2, area 2, that would be equals to minus of pi r square divided by 4. So is it clear up till now? Does it, does it clear? Any doubts? Anything? Anything? No? Great. So what we can do is, let's have an xcm that would be is equals to minus of pi into r cube divide by 4 2s are 8 divide by, it's a pi r square minus pi r square by 4, this is equals to 1 minus 1 by 4, this is 3 by 4 pi r square. So that would be equals to, minus of pi r cube by 8 multiplied by, it is just the 4 by 3, 1 by pi r square. So this pi gone, this r square and r square is gone, only left with the 1 power. This is 4 2 8, this is equals to minus of r by 6. So this is, if this has been considered as a 0 comma 0, this is minus r by 6 would be somewhere here. That is what we were expecting from very first slide. So this is the location of the new center of mass, and if I write the coordinates, it's an xcm comma ycm, then it could be written as minus of r by 6 comma 0. Yes, so again it has been proved that center of mass would be nearer to the body having higher amount of mass. Yes, once you are going to remove this, this segment has less deficiency of a mass, and when this segment has a deficiency of the mass, the other segment has a by default the higher amount of mass, and things will be done. I hope this is clear. So can you do this kind of questions? Can you? Are you sure? Are you sure? Can it be done? Can it be done? Great. Now let's have a little variation over it. Let's suppose the question is, that if given diagram represents sphere of mass m and radius r. This is the sphere having mass m and radius r. This is just the 2D representation of the sphere. If sphere of radius r by 2, this is the radius r by 2, has been removed from the system, find out new coordinates of center of mass. Yes, you need to find out the new coordinates, of center of mass. So now what do you think? What is to be done? What is to be done? What is basic difference between these two? Initially it was disk, and that's why I have taken it's an area. Now it is a sphere. Now in this case it is a sphere, and when it is a sphere, it's an object of 3 dimensions. So what I need to write is, it's an axiom that is equals to v1 x1 minus v2 x2 divided by v1 plus v2. Oh, sorry, it's a v1 minus of v2. Yes, it is the same thing. It is the same thing. It's an axiom that could be equals to v1 x1 minus v2 x2 upon v1 minus v2. Yes, now v1 is the original volume, x1 is the distance, and v2 x2 that you all understand that what terminology defines. I hope this is clear. Is it clear? Is it clear? Are you sure? Are you sure? Can you do this? Can it be done? Can it be? Are you sure? Great. So you will do it on yourself. Yes, you will. This is try yourself. But but I want to add one thing to this question. I want to add one thing to this question. That let's suppose the situation is I have removed this part. Let me show this. I have removed this part and I have added this part over here. I hope you understand that this segment, initially this was the complete sphere. This is the sphere and this was the initial sphere. From this part has been removed and this part has been added. So whatever the segment that I have cut it from here, I have added it on this segment. So if this was the situation, the question is find out center of mass of the system shown in figure. So you need to find out the center of mass of the system shown in the figure. This is required. How will you do this? How will you do this? How it can be done? Okay, what could be the formula? What could be the formula? What I understand is that when I say it's an v1 x1 minus v2 x2 and something, yes, it was the formula that xcm was v1 x1 minus v2 x2 upon v1 minus v2. Why I was subtracting it? Because my mass is getting lesser and lesser. So what I need to do here is that my xcm would be equals to v1 x1 minus v2 x2 plus, why plus? Because I'm going to add the mass, plus v3 x3 divide by v1 minus v2 plus v3. Yes, while saying this I understand that v1 is the volume of original sphere, v2 is the volume v2 is the volume of removed sphere, and v3 it is the volume of re-added sphere. I hope this is clear. And x1 x2 x3, x1 it's a distance of COM of original system from COM. It's a distance of COM of original system from, sorry, origin. And x2 and x3 it's a distance of COM of removed and added part or added system from origin. I hope this is clear. Is it clear? Is it clear? Are you sure? Are you sure? Now, while doing this, you must be careful for one thing, that when you write down the x2, when you are supposed to write x2, yes, this will be visible. When you write down the x2, let me help this, that your x1 is 0 because it is on this location and this would be the 0. When you write down the x2, it is at this location, this is the r by 2. So this x2 would be r by 2. But when you write the x3, because your new system has been added over here, yes, this is the location where new system has been added, and this is the r by 2, but it is in negative of it. So x3 should be minus of r by 2, and then you need to perform the question. So does it clear? Does it clear? Does it make sense? Is it? Will you be capable to do this? Will you be capable to do this? Are you sure? Are you sure? Can it be done? Can it be done? Great. So, is it clear up till now? Is it clear up till now? Ready for the next pattern of the question? Are you ready? Yes? Let's have a look. The question says that this is mass 4 kg. This mass is of 8 kg. Let's say this is the separation between them is the 10 meter. So the question says that if 4 kg mass is displaced by 2 meter in positive x direction, find out displacement, find out displacement of 8 kg body, of 8 kg mass, so that COM of the system remains at same position. So first go through data very carefully. What does it says? What they want? They says that if 4 kg mass is there and it has been displaced by 2 meter in positive x direction, that means it is moving in this direction by 2 meter. Find out the displacement of 8 kg mass so that center of mass of the system remains at the same position. That means even if you are displacing the 4 kg body, your center of mass does not change. How to do this? By displacing 8 kg body. So how will you do this? How will you do this? How it can be done? Let's have a look. This xcm was written as m1x1 plus m2x2 divide by m1 plus m2. Yes, this was the axiom. What I write, it's an m1x1 plus m2x2 divided by m1 plus m2. Now, if I want to write down the change, if I want to write down the change in the axiom, then I can write like this. It's a delta axiom. This is change in the position of center of mass. That could be written as m1 into delta x1 plus m2 into delta x2 divide by m1 plus m2. So this is just the delta axiom. This is the change in the position of center of mass. This is delta axiom that could be written as m1 delta x1 plus m2 delta x2 divided by m1 plus m2. Does it clear? Is it? Are you sure? Are you? Great. Now Now what they want that there should not be any change, because they want that it should be at the same position. So in this case delta xcm would be equals to 0, and when it is equals to 0, this is m1 delta x1 plus m2 delta x2 divide by this is equals to m1 plus m2. So this could be written as m1 delta x1 plus m2 delta x2, that would be equals to 0. I hope this is clear. So let me redraw the system. It was 8 kg, 4 kg. This is 8 kg. This is 4 kg. This was 10 meter, and it has been displaced by 2 meter in positive x direction. So what I need to write down is the m1 delta x1 plus m2 delta x2, that would be equals to 0. My mass 1, let's say this is first, this is second, so this is 4 kg and it has been displaced by 2 meter. As it has been shifted in positive x direction, I keep this as a positive. So if I have considered this as a positive, I must understand that this would be the negative. Yes, so this is 4 into 2 plus 8 into delta x2, that would be equals to 0. So this is equals to 8 equals to minus of 8 into delta x2, and from this delta x2 equals to minus 1. While I say delta x2 is equals to minus 1, what I mean that 8 kg body should be displaced by 1 meter in negative x direction, so that position of COM, center of mass, does not change. So this is to be done. I hope this is clear. Is it clear? Is it great? Ready for one more question? Yes, so that this concept is delivered to the subconscious mind. Let's have a look. This is the 12 kg body. This is the 6 kg body. The separation between them is the 10 meter. Let's suppose it has been displaced in this 2 meter. The question is find out displacement of 6 kg body, so that delta xcm, it's a change in position of center of mass, is equals to 0. That now we understand. So what I need to do is, it is m1 delta x1 plus m2 delta x2, that would be equals to 0. As it has been shifted in positive x direction, let's take it as a positive. This is 12 into 2 plus 6 into delta x2, that would be equals to 0. So this is 12 2s are 24 equals to minus of 6 into delta x2, and while writing this this delta x2 would be equals to minus of 4 meter. This delta x2 would be equals to minus of 4 meter, and while writing this I understand that this is going to be shifted in this direction by 4 meter. I hope this is clear. Is it clear? So will you be able to solve this kind of questions? Even this can be done on the y-axis as well by same methodology. That could be m1 delta y1 plus m2 delta y2 equals to 0, and so on. Does it clear? Does it? Great. So let's just wind it up this session over here. This is all about the center of mass, but this is not limited to this. I have not covered center of mass of different objects, a derivation part, because that part has been already covered in your school sessions. Yes, but center of mass of all those bodies would be required. That is to be remembered. That is the center of mass of semicircular ring, center of mass of we can say it's an center of mass of, we can say it's a semicircular disc, it's a quarter of disc, and all that, all those center of mass will be required. Yes, so please do remember those formulas. I have not covered it purposefully because we want to have more focus on the numerical applications. I hope this is clear. So please, this is the last unit of our mechanics part. From very next session, from very next lecture, that means from very next unit, I'm sorry, from very next unit, we will be leaving the gravitation, we will be heading for the gravitation and all that stuff. Yes, so please focus on this unit, because this unit will have its impact in our physics of class 11 as well as class 12. Please focus this, please do it with very high focus. Please do as many questions as possible of center of mass. In the next session we are going to have a motion of the center of mass, but before we go with the center of mass, we must be very clear, we must be very clear with this. So please do at least 150 to 200 questions to just center of mass of the system. I hope this is clear. Please do it. This is the requirement. This have very high impact in any of the competitive examinations. You take any of the competitive examinations, whether it would be an NEET, or previously it was AIPMT, or now it's a JE or JE advanced, it is having very high impact. Please do it, it's a request. Thank you, have a good day, take care, bye.